The last concept we're going to talk about today is the intermediate value theorem, also known as IVT. This is the formal definition of intermediate value theorem, but on the next slide I'll tell you what it really means to you. It says, if f is continuous on the closed interval a to b, and k is any number between f of a and f of b, then there is at least one number, c, in the interval from a to b, such that f of c is equal to k. What that means is telling us that the intermediate value theorem can be used to determine if a function has a zero within a given closed interval, as long as the function is continuous within that interval. What does that mean? If f of a, if the function value at a is negative, like down in here it is negative, and f of b is positive, up in here it's positive, in order to get from f of a to f of b, naturally we're going to cross the x-axis. We're going to have a zero. So it says there must be some x value, c, in between a and b, which f of c is equal to 0, where we have a 0. For this particular function, the 0 occurs right there. Now, this serves as a warning. The intermediate value theorem only tells us that a 0 exists in between those values. It does not tell us what the actual 0 is. So we have one quick example. The first part says to use the intermediate value theorem to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 within the interval 0 to 1. So what we need to show is that at one of the function values, either f of 0 or f of 1, we get a positive value, and then at the other one, either 0 or 1, whichever hasn't been used, we have a negative value. If that is the case, it means in order to go from positive to negative or negative to positive, we are going to cross the x-axis. So let's plug in 0 into our function. So f of 0 is going to end up equaling 0 plus 0 minus 1. So f of 0 is equal to negative 1. It is negative. Let's find f of 1. F of 1 is equal to 1 cubed plus 2 times 1 minus 1. So f of 1 is equal to 1 cubed is 1, 2 times 1 is 2. So 1 plus 2 gives us 3, 3 minus 1 is 2. So because in our interval from 0 to 1, we go from negative to a positive, it must mean that we do have a 0 within that interval. In order to actually find that 0, you can use your calculator. So I'd like you to plug this function into your y equals, go to second calc, and calculate your 0. When you do that, you should get the ordered pair somewhere around 0.4534, 0. That is the actual 0 that we knew existed between the interval 0 to 1. Thanks for tuning in. We'll see what kind of activity we have planned for tomorrow, but come ready to learn and explain. Have a good night.